For watching. It's quite late here. It's just after midnight, but I'm working on this every day, so here I am back at it. Yesterday, so I guess I'll go over. Yeah, let me do what I've done. Let me show what I've done recently, and then I'll go back a bit, show the kind of the whole project outline for the project. Then I'll talk about what I'm doing today, and my goals for the short term and long term future. So. Um, this is what I did yesterday. These are basically the final tests of the model to show that it's robust. I basically demonstrated this. I have to figure out if I want to do one more test at the beginning of today's stream. So, green was everything that I implemented. Magenta was things that I decided actually applied to the portfolio model. But this evaluating on different regimes, I actually might want to do. Um, so that's what I'm going to be doing today is building up the portfolio model, and I might do one more test on the return model. So this is the outline for the project. Um, whew. So did I? It seems like I deleted some of these. How did I jump from January 4th to January 14th? I may have deleted some slides on accident. But nonetheless, so here's the outline for the project. So I have two goals. The first goal is to beat the S&P 500 by a significant margin in all regimes. So this shouldn't just work in bear markets. It would be a bit odd to develop something only for. Sorry, this shouldn't work only for bull markets, and it would be a bit odd to develop something that worked only for bear markets on accident. But really, this should work on all regimes. If we're in a terrible recession, um, this model should still be working. So that's the first goal: is get a model that works on all regimes. The second goal is to develop a generalized tool that anyone can use. So I'm writing this in Python. I'm generalizing all of my code so that the code isn't just working on a model for me. I'm making a robust code base that anyone can use, and so in like under 50 lines of code, you're able to define a universe for the data. So that's the first thing here is I'm defining a universe. I'm using, so you don't want to use all stocks. If you're using things like penny stocks or low volume stocks, the model's not going to perform well. So if you look at any stock that has really low volume in the stock market, it's, kind of has this unpredictable movement. And so those things are kind of going to make the model perform worse. Also, if it's low volume, you're not going to be able to trade it with any significant amount of money, or at least it gets a lot harder. There's a lot more slippage and stuff like that, slippage in the price. So once you have a stock universe, I'm sending this into the model to train it. So I've this universe, I have data, I've defined the universe. I'm then using that to train a returns model, and I found a universe and returns model that's working really well. So I'll show that in a second. And so the next step is what I'm working on today is the portfolio model. And so really, I guess this is early Saturday morning. To me, it's Friday night. So by the end of the weekend, I want to have this portfolio model completed, and Monday morning I want to start paper trading this model. So if you're interested in that, you should subscribe to follow along. So this is kind of the first iteration of the model. I started this project at the beginning of the year, so this is where I was at the end of January. I started, the first step obviously was getting data. So I started out looking at NASDAQ data. That wasn't going to be efficient because you need to download a CSV file for every stock. And so the next step was cleaning up that, or the next step was finding a better data source. I put the link to the data source I'm using in the description. And so I found this, I guess I'll just go to it. Let me show you real quick the data source. So Dolt Hub, post no preference. This guy's my hero. So he has this data and he updates it every single day. So you see options updated 32 minutes ago. Stocks was updated 2 hours ago. So every day after the market closes, at some point before the open on the next day of the market, this guy updates the data. He has every stock, every ticker that's been listed in the market and in the American stock market going back to 2011, including ETFs. So this is a really robust database. It's really good. So this is where I was at the end of January. So yeah, this is the data I got. I did some basic analyses. So this is looking at fundamental data. This is comparing different stocks in a sector. Um, this is nice, but it's a qualitative analysis. I really need to do a quantitative analysis, and I need something I can automate. Um, and so I incorporated this into a light gradient boosting method model. And the best I was able to achieve was about 51.5% returns. I did find some portfolio strategies that worked with this. The key here is that the best strategy that I found um, was the only one returning a Sharpe above 1. So it was picking one stock per day. I went through and tried thresholding this, and I was able to improve the Sharpe ratio significantly if I used a higher threshold. But the problem is the threshold that worked best was 54%, and if I increased the threshold to 55%, it wasn't making any picks. And so these two things indicate this was a really fragile model, even though it looks good on paper, as you see here in this plot. Oops, never pulled that up before. So this looks really good. But the point is that it's really fragile. So I had to go through and rapidly iterate on the model to find something better. And before I could do that, I had to clean up the code base in order to be in line with my second goal of making a tool that anyone can use, but also just making it efficient for myself. So you don't want to be originally I was writing a new script every time I wanted to do the universe, train the model differently, or implement a portfolio strategy. And that created quickly dozens of files. It was going to blow up to 100, and no one was going to be able to use this code. So I cleaned it all up. I wrote a class for filters. I already had clean data. I fed this into a stock universe class, which then I'm feeding into a model class that I created. And also going into the model class is feature and target classes. So before I did the analysis, I added every possible feature that I could want. And then the next step was kind of plug all those into the model, see how it performs. It wasn't performing very well. I looked at all sorts of different things. This is something interesting I found, which is basically the further you're looking out into the future, the better the model's performing. And so like 5-day future returns is performing better than daily returns. 10 days performing better than that, and 30 days performing best of all. So the longer you're looking out into the future, the better a model does. I got some different metrics to evaluate the model on. And so here's the assessment here on the really good model that I got. And so you see at left are the metrics I'm trying to get and the values I want for them. And you see it's beating it on all metrics except for one. I'll explain that in a second. So information coefficient, we want above 0.01. I'm getting 0.0229. The standard deviation of the information coefficient is 0.1. So here I'm saying that I want it to be orders of magnitude smaller than the information coefficient. But I found this paper here, which is looking at successful analyses of the stock market. So basically successful models, successful strategies. And it's finding that the standard deviation of the information coefficient is larger than the information coefficient, usually by an order of magnitude. It's 3 to 13 times larger. And so here, I was initially concerned about this standard deviation value, but you see this is actually only about 4.3 times as high as the information coefficient. And so this is right in line with successful strategies that have been published. Finally, the information coefficient to information ratio, I'm looking at that both daily and on an annual basis. So daily, you want better than 0.02. I'm getting 0.22, so way better by an order of magnitude. And then on an annual basis, I want better than 0.3, and I'm getting 5 times higher than that at 1.58. Finally, the T statistic, you want above 1.96, and I'm getting 2.3191. And so this was a really good model that's beating it on every metric. I went through earlier this week on Monday and Tuesday. I was trying to improve the model by adding fundamental features and adding sector information. The problem with this is the database I'm using has fundamental features only going back to 2023. Um, and so since, hey, Sir Night Night, welcome again. Thanks for joining. So the model's only going back to 2023 for fundamental data, and like I said, the price data is going back to 2011. So since I have price data and fundamental data, I basically have a few choices to make. The first thing I could do is exclude the fundamental data altogether from my current model. The downside of this is that it wouldn't, fundamental data would be a significant improvement to the model performance. My other choice was I could change the training, so only train on data since 2023. The problem with that is that if I'm only training since 2023, that cuts my training data down from, let's see, so it goes from 15 years of training data to I would only have under 3 years of training data. Basically 2 years of training data compared to 14 years of training data. And so that would be a huge downgrade to the model, so I didn't want to do that. My other option was go through the SEC Edgar database, which lists all fundamental data, and they have it for tickers that have been delisted too. The problem is that those tickers that have been delisted, it's really hard to get information for those. It's not straightforward. So the SEC Edgar database has a list for all current tickers. They have a code corresponding to the tickers, and you could easily go pull the data using web queries. What's it called? Requests. Basically, you send a request to a web page, and you can get the data back. And and so I can't do that. I can't use this simple SEC mapping that they have because that would create a survivorship bias. And I would be not looking at any stock that dropped out of the stock market between 2011 and today. And so that would totally bias the model, and it would basically ruin the model. It wouldn't be any good. And so I couldn't do that. And so really I had to go through the SEC Edgar database and do a really kind of a complicated thing, pulling all data for delisted tickers. And that was going to take a really long time. Honestly, that's a whole project in and of itself. I'm going to do that in the future, but I want to get a model going as quick as possible. And so I chose to do the first option, which is just exclude fundamental data for now from the model. But I will be implementing that in the future. And the other way I tried to improve it was including sector information. So that you can also get from the SEC Edgar database. But I wrote a script to pull that information from the database. The problem with that was I was only getting sectors for about half of the tickers I had, which wasn't going to improve the model either. And so I chose to drop that out. And that basically gives me, once I complete these models and I'm paper trading with them, while I'm doing the paper trading, that will be my next project, is go through and pull all of that data from the SEC Edgar database. But I want to get a model going. I think not only will this be, it's the goal for me, kind of this is a thing with projects with me, is you can get sidetracked, and next thing you know, it's the end of the year and you don't even have a model that I've paper traded. And so I don't want that to happen. So I'm going to paper trade with a simple model for the main reason is that it's hitting every metric I want. And so that's what I decided kind of at the middle of the week. One more thing. I tried to improve the model using macro features. So looking at the volatility index and then also treasury rates. So interest rates from the Federal Reserve. The problem with these is the models... I'm normalizing the model across all stocks. And so I'm looking how are the stocks performing relative to each other. These macro features like volatility index, the value is going to be the same for every stock. And so this is actually, when I tried this, it made the model worse. However, you can see here, I did incorporate the, I don't have a slide where I'm demonstrating the volatility index. But this is the interest rates. And so here I started looking through the interest rates, what interest rate features can really improve the model. And so I tried all of them. Then I tried only doing the spread in interest rates between long and short term. And then I realized that these aren't, for the reason that I just said, these aren't going to improve the model at all. So the final step was going through and testing the model robustly. And that's what I was doing yesterday. And now I'm confident that I have a really good model. These are the tests I did. And what else? I think that's mostly it. So right now, yeah, so now I'm into working today. So all that said, please subscribe if you're interested in this project. It helps me out, obviously. It also helps me out if you like it. It also helps me out if you go to the GitHub and check out the repository. Try downloading it for yourself. Like I said, you can create your own universe and model in under 50 lines of code. I'm hoping that after today I'll implement the portfolio class, so you'll be able to get a portfolio. You can train and assess the model right now in under 50 lines of code. You can make a model with any of the features that I showed earlier, so all features on price data. And then also, speaking of the GitHub, it really helps me out if you star the GitHub, watch the GitHub, and follow me on GitHub. That helps raise my profile for freelance gigs and coding jobs. And finally, join the Discord. There's a link for all this stuff in the description. The Discord, we're just going to talk about interesting things. So let's get down to business. So I want to evaluate the model on different regimes. I'm trying to figure out, so do I want to evaluate just the model? That would be interesting, looking at the information coefficient in different regimes. Really, I don't think that would be interesting because it's looking at how the stocks do relative to each other. So really, I don't know if that should change much in different regimes. I'm going to look at that for the portfolio strategy. So, if the portfolio strategy is performing really poorly in certain regimes and I'm not able to fix that, then I'm going to go back into the model and look at this. But for now, I'm going to get working on the portfolio strategy. So here's the code. Yeah, and this is the portfolio. So I started writing this last night. Obviously, I didn't get very far. So I need to think a little bit about how to implement this. So I'm going to pull up Google Gemini and Google AI Studio. This is Gemini 3.1. It's the most useful free model I've found, but they limit your number of requests. But like I said, it's the most useful one I've found. So that's what I'm using. Let me know if there's something I could use which is better, but this is what I'm doing for now. So let me just think about how I want to implement the portfolio. Oh, so the first thing I want to do is get model. Actually, so I might not only want to be implementing this in the portfolio. So I'm gonna call this retrieve model. Oh, it's gonna be a function. So and I'm gonna pass in model folder. And then here, when I want to get the model, I can just say self.model. All right, I'm going to do pass for now because I need to think about what this is going to do. So yesterday I wrote some saving logic for the model so that I can retrieve it later. Basically, you don't, since there's a bunch of features in the model, and you don't want to have to go back and look at how did I define the features and then rewrite the code for pulling the features. So I have this feature engine here, which gets all the features that you want. So you define the features you want with this feature request class. You could also define rate features here because those work a bit differently. Either of those rate features or just feature requests. Rate feature requests or feature requests you can pass into this feature engine. And then when you do this compute function, you pass in a pandas data frame. The data frame has to include open, high, low, close volume data. And then it will go through. This automatically computes every feature that you want. And this is really flexible, so it's easy to add any features here. Yeah, so that's kind of the point of that. And so this portfolio model, I'm going to incorporate features as well. These are going to be macro features. So where's portfolio? Okay, let's just pull it here. So, analysis, clean analysis, Dolt reader, feature engine, feature pipeline, fundamental. Oh, this. Yeah, so yesterday I wrote some logic for saving the model. So this is what the model looks like when it's saved. When you're creating the model, you pass in a folder for the model. So let me go here and pull up the folder for the repository. So work and then stock market tool. Data. Let's just make this bigger. Models. And so this is what I saved yesterday, model 12. So if you go, but it'll save as whatever I name it. So this model, I was iterating through models, and this is the 12th model I tried. So this is the saved model 12. And the last thing yesterday was actually a really good, nice thing. So I added an embargo on the data. I separated the data. Basically dropped a bunch of rows, dropped a bunch of dates out of the data that's in between the testing and validation data set, and also, the training and validation set and the testing data set. I dropped out a bunch of dates in between those, and that actually improved the performance. So, just a sec. I have too many things open right now. Yeah, but so this is saving basically LGBM in Python. You can save a model and then read it right back in. I've pickled the target feature, and then in here in features, I've pickled all the features. So obviously, I have a lot of features, 103 different features. The point here is that this is really small because this is just pickling the feature requests, not any data itself. And since I already have this fundamental engine here, it's really easy to go back and get the data. If you look at the size of this, it's only 426 kilobytes. The whole model folder, you want the things that you're saving, you want to be really clean, and then any big data sets you don't want to be saving on disk. You want to recompute them only when you need them, and then hold them on your disk only when you need them. So the whole model folder is only 143 kilobytes. So you're able to save models in a really condensed format. So this is the model saved from the light gradient boosting method. And these are all the features. So what I want to do now when I'm getting the model, I want to pull all of these back in and then put into this class. So, this is the model explorer. So here's the model class. So I want to create a object of this class, which holds all the data. So I'm going to pass in the model folder, and then I'll say, so now we need to look up, what's it called again here? LGBM is just the name of the Python package. Oh, LightGBM. Okay, so LightGBM. I want to read a model text file. All right, so, and then what's this saving as in the model class? I think it's just self.model. So in train model, I'm saying self.test model. Oh yeah, so I create the model here. So this is the model I want to get back. So when I'm saying retrieve model, I'm going to say, first we give it the model is equal to LG. Oh, so now I need to import LightGBM as LGB. And then model is equal to LGB dot, how do I read it in? Dot booster, LGB dot booster, and I want to say model file is equal to the file path. So model file is equal to an f string, and we want to give it the model folder slash model dot text. So that's going to pull the model for me. I'll just call this LGB model is equal to that. Now I want to create the model class. Oh. Yeah, so then I'm gonna have to do universe data. Actually, yeah, so I need to change the saving functionality of the model. So, train model, if we have the folder, we want to save the model there. But not only that, we want to create some information. So info is equal to an dictionary. And what information do I need? So I need to know the train test split. All right, so here when I'm getting the train test split data, I think I call it. Yeah. So cutoffs. And so here, if self.has folder, we're doing that. Oh, good. So I have the dates. So then I'll just say self.dates is equal to dates. And then here, let's just do, okay. So I guess instead of saving the dates to here, we can just say dates, dates is now dates df is equal to pd dot data frame of dates, and then we could just say dates df dot to csv f string, so we want to give it to the model folder, so self dot model folder slash dates dot csv. So that will be the date information. What other information do I need? So I need the dates. So in train model, I'm trying to save it here. So I've saved info. I don't need that. So info, what else should go in info? So I'm trying to read it in here. I need the model. Oh, I need the universe. Universe name. So I'm actually not passing in the name of the universe, so I'm gonna change that here. Yeah, but then how do I make it flexible? So here I'm gonna give it universe path, and then I'm gonna say, so rather than self.data is universe data, I'm gonna say it's universe path. Let me put a note in right here that says universe path should be the path to the universe file saved as feather. Because feather's the best way, or the most efficient way to save it. Okay, so self.data is equal to pd.read feather of universe path. And then in the model explorer, so I don't want the model explorer to break. So now, I guess I'm gonna change it for every model now, because yeah, I want all of the previous models to work. I'm just gonna change it for model 12 because the previous stuff isn't working. So, let's do model is equal to that. So instead of universe data, we want to give it universe path. And then here I'm getting universe data. Where's universe data defined? Oh, it's right here. So I'm going to say universe path is equal to this guy. Let's make that look nicer there. So I'm not going to bother reading in the universe data here. It'll happen in the model folder. Okay, and then I'm gonna say self.universe path is equal to universe path. Train model. Okay, so universe name is, I'll just to be consistent, I'm also going to call this universe path is self.universe path. Do I need anything else? Let me look at this. So first I just make all the features. Then I make the target. Then I make the model. Add the features. Add the target. Split the data. Train the model. So all I'm going to do is, yeah, since I have the dates, this should work. So first we're getting the model. Now we're gonna say, okay, so let me run this real quick. So model explorer model 12 is running. This is just a bunch of crap. Work stuff. Okay, so this is, yeah, this was the sector data. So you see, so many of these are unknown. What I'm worried is happening here is that it's not finding the data for the tickers which have been delisted. But like I said, that's going to be like a really complicated thing to dig into, and it's going to take a really long time. So I'm going to leave that out for now. So let's get out of data retrieval. Let's go to explorers. And let's do model explorer.py. So this is going to run model 12 again. Just to make sure, let me make sure model 12 is turned on. Yep. Okay, so the first thing I'm doing, oh wait, I don't think I saved that. So let's go back to the model, test model, so in train model, yeah, so I've got info. I think that's all the information I need. Then I'll say info.toCSV. So f string self.model folder slash info.csv. Okay. Okay, now let's run this. So now it's going to resave the model. So the first thing I'll say is info is equal to pd.readcsv. Okay, so we need pandas. And we're also going to need feature engine. So from feature engine, import everything. Real quick, I actually had this thought yesterday. So I was saying that this doesn't include fundamental data going back that far, but it might be. I was just looking at the first value in the data set. Let's see what he says here. Contains the following tables. Data is recorded weekly on the weekend for estimates. So do I have the fundamental data actually saved here? Clean interest. Oh yeah, I do. So let me just look in this real quick. And I want to see, do I have the data? What's the earliest date in the data set? So fundamentals is equal to pd dot read feather, and we want to read dot dot slash, where am I? Yeah, explorers. So I want to read dot dot slash data slash quarterly fundamentals dot feather. So let's do fun dot date dot min 2016. So that's actually way better than I thought. We're not limited to 2023 data, but it's a bit, do I want to cut 5 years out of my data set for now? So that actually, I've written a lot of the logic for reading in the fundamental features. So I'm going to do this first model just on price data. Then it will be pretty easy. Probably before I'm done paper trading this model, I'll get to incorporating the fundamental features. Okay, so now we want info, so read CSV, another F string, and we want to go to model folder slash info.csv, and then dates is equal to pd.readcsv. Same thing, model folder slash dates.csv. Okay. What? Oh yeah, it's in here. So we have dates. .csv. Yeah, actually I'll just retrieve that. And then we're gonna say features is equal to, okay, so I'll say features is an empty list, and then we'll say for, so here we need to import OS. And then for file in os.listdir, another f string, we'll do model folder slash, what's it look like again? Features, I think. Okay, so data, models. Oh yeah, duh. So when I'm doing the dates, these need to be lists. And let me look at the other one I'm saving. So train model, info.2csv. Okay, so this should be a list as well. Save. Now we could run this guy again. So then we're going to say for file, and so we're going to get the model folder slash features. So let's get the features folder. We're going to say features dot append and pickle. So I need to, these are all pickle files. Read file. So with file, so that's just going to get the file. So I'm going to, again, this is going to be an F string. We're going to go to model folder slash features slash file in read binary mode, and the string here. And we'll do this. Feature is this, and then we'll say features.append feature. Yeah, so here we need to import pickle. So features.append feature, and we're going to put this in a try except loop. So if for some reason something saved wrong, we'll catch it. So trying this, if this doesn't work, we're going to raise an exception and say feature f string. We're going to say feature file could not be read. Okay, and then assuming it works, so this will raise an exception. If no exception is raised, we'll append the feature. So now we have features. So then let's get the target is equal to, so we'll do the same thing as this and change it. So with model folder slash target dot pickle pkl, right? We're gonna say target is equal to pickle dot load file. So here instead of file, I'm going to say for feature file in here, because I'm using file again here. Feature file is file, do that. Otherwise, say feature file could not be read. Okay, then we get the target pickle dot load, not pkl, file. Okay, so is there anything else we need? We have feature, target, dates, model, info. Yeah, so now we could just say return. Yeah, return LGB model. Info. Do I want to return everything here, or do I want to just put it into a model class? I guess I'll do the former. So LGB model, info, dates, features. Okay, so here's the results for the model. I mean, not like that's too interesting right now. I'm not prototyping. You gotta be kidding me. Another error. Yeah, so info df is equal to pd, it's because I'm tired, pd.dataframe, and we're going to put info into the data frame, and here we'll say info df is equal to this. I'll run this again, and by the time I'm done writing the logic, this should be done, and I'll be ready to test it. So we're going to read back, return LGB model, info, dates, features, and target. Okay, so now here we can say same thing. LGB, I'll just copy this. These guys equals retrieve model. Okay, so I'll say this guy retrieve model is a gets model information from model folder. This is a string, and path to the model folder. It raises an exception. Feature cannot be found, and then it returns. So what would that be? That's a tuple. And info for the model. So these guys is equal to retrieve model of self.model folder. Then let's add another function and say, so we want to get the model, and then I guess inside get model we could just make it. So then we could say from clean analysis import model universe. Because I don't want to import the universe filters. That's already been defined in the universe. Do I need to import universe? No. So just import model. And then I'll say, now we have all of this. So we'll say self.model is equal to model. Do I pass anything into the model? I don't think so. Universe path. Yes, I do. And then model folder is defaults to none. So all we need to specify here, since we already have the model trained and we're opening it, we just need to say universe path is equal to info dot I guess I could just say here, since there's only one thing, universe path is equal to info dot, what am I saving it here? Info dot CSV. So info dot universe path. Of 0. Okay, so we've defined the model. Now we want to say self.model.add features, and we could just pass the features in. Then we want to say self.model.add target, and pass in the target. So the next question, do we care about any of the training data? I don't think we do. So yeah, so here's the model again, the features. Let's see if everything works. Here's the results. Obviously this looks really good. And yeah, okay, so it works. So this is everything now. So universe path is equal to info dot oh, I'm not doing that anymore. So let's just get rid of this guy. So I have the model, and then we'll say self dot model is equal to, so pretty sure this is self dot model. Yeah. So self.model.model is equal to LGB model. And next we just have the dates. So so what's that look like? Oops, not get info. We want to do quick look. So we want to do dates of test cutoff of 0. Well, the test cutoff, all right, so how am I doing this here? So test cutoff, oh, so that's why the information coefficient was so much better, is the test is way smaller. So let's do this one more time. Let's do the time warp again. Let's run the model again. So 0.7 to 0.85 is training. So I'm going to change this. It's going to do 0.5. The first 50% is training. Then to 0.65 is testing. And then use the rest of it for, 0.65 is validation. Use the rest of it for testing. Then I'm going to run that. So it's I'm giving it a lot less training data, but that'll give it more testing data after the embargo. And let me see how it performs. So back to portfolio. We're getting the model. Oh yeah, let me look at how the dates are being saved. So in, what is it, split data? Test cutoff is, oh, so those don't change. Where's the embargo? Oh, here's the embargo. So gap offset, shift the validation data and test start dates forward by both the purge and embargo gap. So that's what I don't understand. 0.85, so the last 15% of the data set. That's not making sense to me. Why is it cutting off so early? So test cutoff. Quick look. Universe 1. So why would the training cut off? Oh yeah, because here I was using 70% of the data, so that does make sense. But then the next 15% of the data is 3 years. So I'm going to need some better logic for that. Oops, split data, split data, split data, split data. Here we go. Where'd the AI go? Okay, I'm gonna go get my headphones real quick so I could listen to music while I do this. Be right back. Okay, so let's see what it says. So if you just tuned in, please subscribe, like the live stream. I'm working on getting a model for the stock market. Here's my strategy. Um, so this is what I want to do. I have two goals. First goal is beat the S&P 500 by a significant margin in all regimes. So not just bull markets. It should work on sideways markets, bear markets. I should be not only beating the S&P 500, but making a lot of money. So like, I don't know, 20% return average over all regimes. Maybe I should change this to say. And then here, not only do I want to make a model for myself, I want to generalize the code to make a Python tool that anyone can use. So the progress I've made on this, this is what the outline looks like. So I'm isolating a universe of stocks with data. It'll have data for each stock each day that it's in the universe. I'm using that to train a model. I have a returns model, which is working really well. And so now I'm feeding that into a portfolio model, and I'm writing the logic for the portfolio model right now. And I have a usable Python tool anyone can use for these first two steps. So you can create a universe and train a model in under 50 lines of code, and then you can assess your model all in under 50 lines. So this is really efficient. So if you're interested in that, you can go to the GitHub, which is in the description. And if you use it, please star it, watch it, and follow me on GitHub. That helps me raise my profile for coding jobs and freelance gigs, which is something I want to do. And also, thanks for watching. So let me put some music on really quick. Here's the results of the model. So this is actually really good. So I gave it way less test data. So now you can see if we look at this guy, dates, quick look, the dates are the same. So did I not save Model Explorer? But anyway, we have to change this. So here's the exact lines to replace it with. Train and, oh yeah, okay, cool. Self.model folder / date. So that's the only thing I have to change is this guy down here. Paste it, save it, save the Model Explorer, and so test model 2, oh crap, I don't want that there, I want model 12, so that's why it didn't change the split at all. So model 12, when we're splitting, we want to do, no, that's correlation matrix, so this is model 12. So here, give it 0.5 to 0.65. So first 50% is the training, next 15% is the validation, and then the final 35% will be the test. Okay, let's get out of here. Yeah, so we already know how that's going to look. And run it one more time. So this stuff should all save. Okay, so now we have test start and test end. So when I'm making the model here, before I generate all features, so I don't want to generate it on the whole data set because I'm only going to be training the portfolio on the test data because, you know, we don't want any data leakage. So we'll say start date. I guess I could just say self.model.data is equal to self.model.data and where this condition and this other condition. So the first condition is going to be self.model.data.date is greater than or equal to dates And where was that? Get here. Dates of test start. So where it's greater than or equal to, I'll just say dot test start. So we want to get where it's greater than or equal, so basically get the test data set. So where it's greater than or equal to test start, and where this guy, so instead of test start, we're going to do test end. So now isolate the data. This will make the feature generation way faster, especially since, what is it? Like a third of the data set's going to be the tests. So instead of getting the features for the whole data set, we can get the feature and target for just the test data set. So finally, the last thing here will be to generate the features. Split data, so now we want to say self.model.add features, features, and then we want to say self.model, oh, we have it. So self.model not add features, we want to do tune params, generate targets and features. So self.model.generate targets and features. Okay, so now here's the portfolio class. We're going to initialize it, and then upon initialization, it should just get the whole model. And then now at this point, I'll have the model exactly as it exists when I'm creating it. And so, all right, I need to think about the structure. So help me think about the structure for my portfolio class. I want to use a differential evolution algorithm to assess to optimize the portfolio strategy. What sort of macro features should I be looking at? I already, all right, so whoa, if I trim the test data, if I trim the training data way down, suddenly it's not performing as well. Now that makes sense. With less training data, it performs worse. Okay, so what was it at? So Model Explorer, split data. So I'll just copy that guy. And so let's go back. I don't know, 6.5. So model 12. I hope I wasn't going on a wild goose chase here, but maybe I was. So originally I was splitting the data like this, then I changed it to that. So let's see. Originally I was, and here's the results for that. So, you know, we still get a, you know, it's a very skewed distribution now, but at least it still looks kind of like a staircase. But what I'm worried about is all the metrics are much worse now. So originally I was training the model on... Okay, and before I look at this, let's see what were the dates that it split on. Oh, why do I keep doing that? Get info instead of quick look. So quick look. So the training went from 2013 to 2019. So why does it not start in 2011? Validation, August 2019 to April 2021. Testing, 2021 through 2025. So originally I was training my model on the first 50%, what was it? First 60% of my data. I training the model on first 60%, validating on the next 20%, and testing on the final 20%. This model was beating each of my goal metrics. So goal metrics are information coefficient to information ratio, standard deviation of information coefficient, and t statistic. Okay. I changed the model to train on the first 50%, validate on the next 15%. So it might just be the validation data set's way too small. And test on the final 35%. Once I did this, the model performed much worse. And is not beating my goal metrics. Why I am consider that I am performing a significant data embargo and purge as implemented in the code I gave you in the previous prompt. What accounts for the decrease in model performance? What is the typical splits quants use on their data? Whoa, real quick. The universe, I'm almost positive this goes back to 2011. So when I'm getting the universe, what am I doing? Yeah. So it's going 2011 to 2026. So does it actually start in 2013? Okay, let's see what it says. collapse simply by moving chronological boundaries is a fantastic, albeit painful discovery. Yes, painful indeed. You have just encountered non-stationarity, which is the final boss. Well, at least I'm at the final boss. If a strategy's edge disappears when you shift the testing window backward by 15%, the 60-20-20 success was likely an illusion. Here's exactly what accounts for the, oh no, so I mean, just as you said, Sir Night Knight, this is how it goes. I guess I'm not ready for paper trading. So the validation squeeze and regime shift. Okay, there are 4 converging reasons why your 50-15-35 split is failing, where your 60-20-20 split succeeded. In 60-20-20, the validation set covered 60 to 80% chronological chunk. So that was a lot of validation data. Your test set was the 80% to 100% chunk. The data from the 65% to 80% window moved from the validation set to the test set. In your first setup, Optuna was essentially peaked at the regime to pick the best depth tree learning rate in early stopping rounds. The model was optimized for that specific market environment. Okay. Yeah, okay. Starving. Yeah, well, 2022 was a bear market. So, good. So 2022, I do want included in the test. Really, the question here is, why did the start of the training data begin in 2013? Price equals pd.read feather, and we're going to look at all ohlcv.feather. Oh, data. So let's go / data / all ohlcv.feather. Price look at the previous function I gave you. My data starts in 2011. Why is it only getting training data going back to 2013? What the hell? Alright, so let's look here. A 35% test set is too long for a static model. Starving the LightGBM. Financial data has an extreme... I forgot. I need to do the walk forward. Financial data has an extremely low signal to noise ratio. Dropping your training data from 60 to 50%. Yeah. So I need as much training data as I can. Furthermore, because you're using a 1% embargo and purge gap, the actual amount of usable training data is even less than 50%. You may have crossed a threshold where there's not enough examples. The 35% test set is too long. A 35% test set in a 10-year data set is 3.5 years. No quant deploys a static machine learning model and lets it run untouched for 3.5 years. Financial markets evolve, correlations break, and alpha decays. Expecting a single LightGBM model trained on year 1 to 5 to maintain a high ICIR through year 7, 8, and 9 without retraining is almost impossible standard. Research overfitting. When you looked at the results and said, oh yeah, well, okay. What splits do quants use? Instead, quants use dynamic validation techniques. So this is probably what you were talking about, Sir Night Knight, in your previous comments. Walk forward, rolling cross validation. Instead of one massive split, You simulate exactly how the model will be used in live trading. You train the model, predict a short window, then retrain the model as new data becomes available. Fold 1, train on years 1 to 5, validate on year 6, test on year 7. Next, train on years 2 to 6, validate on year 7, test on, expanding window cross-validation. But the training set grows over time rather than dropping old data. Okay, so I'm going to need to write some... I need to write into the code basically some logic for doing this walk-forward analysis. Yeah. Combinatorial purged cross-validation. Standard walk-forward testing has one flaw. Your model only ever gets tested on the most recent data, meaning you only get one historical path. What does that mean? Alright, well, this is an update, so let me put this into the PowerPoint. So I changed from 60-20-20 split to 50-15-35 split. What a disappointment. So let me look again at my goal metrics. And I'm actually going to put this into the table because, yeah. So what do we have? We have metric name, target value. And then one, so we have IC, standard deviation, ICIR daily, ICIR annual, T statistic. So metric and goal. So first IC standard deviation, ICIR daily, ICIR annual, and T statistic. Okay. So information coefficient, we want 0. Above 0.01 to 0.02. Standard deviation, we want less than 3 to 13 times information coefficient. ICIR daily, we want above 0.02 to 0.03. ICIR annual, we want above 0.3. And T statistic, we want above 1.96. 1.96. And then we're going to say here above 3, even better. So information coefficient 0.0093, getting close to the goal but not there. Standard deviation is now about so it's right at the top of this, so it's hitting this but just barely. ICIR daily is 0.08, so that's good. Annual ICIR is 0.57, so that's good. T statistic 1.09, not good at all. So it's not hitting all the stability metrics, and it's below the return metrics, so that's not good. All right, so let's go back and see what it says. So fixing model. What's today? 3/21. Okay, so what do I want to do? Let me think. Okay, so what's it say to do to improve this? So implement walk forward analysis, implement combinatorial purged cross validation, CPCV, so I'm going to say how is, oh, here. Oh, universe selection. Right, so I'm losing 2 years because I need the metrics going back a year for the universe, and I need metrics going back a year for the features. Therefore, it's only starting in 2013. Okay, well, at least that makes sense. Alright, so how is Lopez de Prado an improvement over CPCV? Let me finally put some music on. Babe, don't make a sound. Oh, okay. Running on my innocence, on my. So don't write any code, but tell me what exactly I am going to need to change to implement the CPCV from SK Folio. Period. On my sensor. Yeah, I could just give it the model class, that'll be fine. I always feel like somebody's watching me. Somebody's watching me. Okay, 12,000 tokens, that's a lot. Yeah, so if you just tuned in, please subscribe. Please go to the GitHub, star it, watch it, follow me on GitHub. All that stuff helps me out a lot. Somebody's watching me. Split data is the biggest change. Right now it's doing one model. Under CPCV, your objective function must iterate over the cross-validation splits. Yeah, so I'm getting a bunch of models. Train model, instead of doing it once, it will enter a for loop, combining over every split combination. But really, it'll be fine because the model for the portfolio is just going to be the most recent. Oh, right. So I want to train on as much data as I can. So let me put this here. So change data splitting, change parameter tuning, change train model, change model test. So get distributions of evaluation metrics. Okay, so that's going to be it for tonight because it's 1:40 in the morning. Unfortunately, so I thought I had a really good model. I changed the split of the data, and it turns out the model isn't robust. So I'm going to have to go through. I'll do a stream later today where I'm working on that. So my goal for the next stream is to implement all of these things and then test the model with this better analysis. So and then see how it performs. And if it performs well, great. We could go forward and use it with this more advanced model. This should improve the values, so it should give better values than this. But if they're still not good enough, I'm going to have to go through and add sector information and possibly add fundamental information, which will, then take quite a while, probably several weeks of figuring stuff out for that. So with that said, that's it for tonight. Thanks a lot for watching. Don't forget to like the stream and subscribe. Have a good rest of your day. Adios. Not good enough. I'm going to have to go through and add sector